Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video we will solve together a new problem contains questions about the natural logarithmic function. Given the function f defined over 0 plus infinity as f of x equal x into x plus ln x plus 1 over x plus 1 square, see its representative curve. The curve C cuts the x-axis at the point of abscissa alpha positive. Let us see the curve of f. This is the curve of f, and this here the number is alpha. The number is alpha. Give the sign of f of x and verify that ln alpha equals minus alpha plus 1. The sign of f of x varies from 0 to plus infinity, not defined at 0, at alpha equals 0, between 0 alpha negative, the curve is below the x-axis, at alpha 0, and between alpha plus infinity, the curve is above x prime x, the function will be positive. How to prove ln alpha equals minus into alpha plus 1? So, alpha is a root of the equation f of x equals 0. So we have f of alpha equals 0. F of alpha, substitute x by alpha equals 0. Alpha is different from 0, and alpha plus 1 square is also different from 0. Then this fraction is 0 when alpha plus ln alpha plus 1 equals to 0. So ln alpha equals minus into alpha plus 1. Consider the function g defined over 0 plus infinity as g of x equals x ln x over x plus 1 plus 1. Designate by g its representative curve. Calculate limit g of x as x goes to plus infinity and limit g of x over x as x goes to plus infinity. Let us see. As x goes to plus infinity, here we take x common factor in the denominator. We got x into 1 plus 1 over x. X simplified, 1 over x is 0. So we still have ln x. Ln x goes to plus infinity, plus 1 plus infinity. This is limited g of x as x goes to plus infinity. Limit g of x over x as x goes to plus infinity. If we divide by x simplified, 1 ala x plus 1 here, x plus 1 goes to plus infinity faster than ln x. 1 over x also goes to 0. Then the limit of g of x over x as x goes to plus infinity equals to 0. Let us see. Limit g of x as x goes to plus infinity. This is limit x ln x over x plus 1 plus 1. Take x common factor, x and x simplify. 1 over x 0. And we still have ln x over 1. So this is plus infinity. Limit g of x over x as x goes to plus infinity. G of x over x, okay, so we simplify by x, so we got ln x over x into 1 plus 1 over x. 1 over x 0, ln x over x as x goes to plus infinity 0 because x is faster than ln x, so here 1 over x is 0. Prove that g of alpha equals 1 minus alpha. G of alpha is alpha ln alpha over alpha plus 1 plus 1. We have to get rid of ln alpha. How to get rid of ln alpha? We go back to alpha. Alpha is a root of what? Of f of x equals 0. G of alpha equals alpha ln alpha, etc. And since we have ln alpha equals minus into alpha plus 1 because alpha is a root of f of x equals 0. Alpha plus 1 simplify, we got 1 minus alpha. Verify that g prime of x equals f of x over x. G prime of x, g of x has the form of u over v. The numerator has the form of u times v. Okay, u prime v. What is u prime v? This is product of two functions. U prime 1 v ln x. U prime v, so ln x plus u v prime x darb 1 over x. So then we got ln x plus 1. This is u prime v x plus 1 minus u v prime minus x ln x darb 1, and the derivative of 1 is 0. Why this is f of x over x? Because f of x equals how much? F of x into, if we divide this quantity by x, we still have x plus ln x plus 1 over x plus 1 squared. So this is f of x over x. Calculate limit g of x as x goes to 0 plus. What do you conclude? Limit g of x as x goes to 0 plus equals limit x ln x over x plus 1 plus 1 as x goes to 0 plus. As x goes to 0, x ln x goes to 0 minus 0 over x plus 1, so 0, we get 1. What do we conclude? We conclude that the point of coordinate 0, 1 is a limiting point. Set up the table of variation of a g. G prime of x takes the sign of f of x. So this is minus plus, decreasing, increasing. Limit of g of x as x goes to 0 equals 1. Limit of g of x as x goes to plus infinity equals plus infinity. And this is 1 minus alpha. G of alpha equals 1 minus alpha. Let h be the function defined as h of x equals g of x if x positive, x plus 1 square if x less or equal to 0. We have to prove that this function is continuous at 0, because it's continuous for every x different from 0. If x is positive, h of x equals g of x, continuous. If x is negative, h of x is equals x plus 1 square is continuous. We still have to prove that to study the continuity of h of x at 0. The domain of definition of this function is minus infinity plus infinity, because for x positive, g of x is defined. For x less or equal to 0, x plus 1 square is defined, so the function is defined over minus infinity plus infinity, and the function is defined in a neighborhood of 0. Limit h of x as x goes to 0 plus. H of x in this case equals g of x, and the limit of g of x as x goes to 0 plus equals 1. Limit h of x as x goes to 0 minus. In this case, h of x equals x plus 1 square. We substitute x by 0, we get 1. And h of 0, how to calculate h of 0? From the second expression, this is 0 plus 1 square equals 1. What do we conclude? Limit to the right hand side equal limit to the left hand side equals f of 0 equals h of 0, then h is continuous at 0. Set up the table of variation of h. The domain of definition is minus infinity plus infinity. If x is negative, h of x equals x plus 1 square. H prime of x, this is u to the power n, and u n minus 1 times u prime, so 2 into x plus 1. 2 into x plus 1, the derivative vanishes at minus 1, and it changes the sign. The table of sign of h of x starts by what? By minus. So minus plus, minus plus. we have to study the sign only over minus infinity 0. Minus plus. If x greater than 0, h of x equals g of x, and we know the table of variation of g of x. H of x, so decreases, increases, decreases, increases. Alpha 1 minus alpha at 0, 1, minus 1, 0, alpha, alpha. The limit of h of x as x goes to minus infinity is the limit of x plus 1 square equals infinity. So we have an asymptotic direction parallel to what? To y prime y. Okay? And here we have an asymptotic direction parallel to what? To x prime x, because limit g of x over x as x goes to plus infinity equals 0. Calculate limit of h prime of x as x goes to minus infinity and construct ch. Limit, it is limit of h prime of x as x goes to minus infinity equal minus infinity, because h prime of x equals 2 into x plus 1. Construct the representative curve of h. So decreasing, increasing, decreasing, increasing. Thanks for following and good luck.